welcome to the Let's Clear the Air podcast. I'm Adam Murray, alongside with my co-host, Bryan Nix. Stuart Salters is out today, so we'll wish him well. But today we're joined by Janice Tran, the Chief Executive Officer of Kanin Energy. Janice has an impressive background in energy innovation. While at Generate Capital, she built a very large portfolio of anaerobic digestion assets. She was also part of the early team at NRG's microgrid business line, and is the co-founder of Student Energy, the largest global charity focused on education for post-secondary students on energy issues, and currently sits on their board. Also, as full disclosure, my company, Samuel EPC, has partnered with Kanin Energy on several projects across the U.S., but we're going to be discussing aspects of the waste heat to power technology that's used in some of those projects. So, Janice, welcome to Let's Clear the Air.
Yeah, no, thank you so much for having me. Really looking forward to this.
Well, let's dig into some of the items in the past work before we get into Kanin. First, we mentioned the anaerobic digestion. You know, for those who don't know, what is that and how do you use it to produce energy?
Yeah, definitely. So yeah, as you were saying in my intro there, I worked at Generate Capital for about 5 years there and was director of investments on their investment team, focused really on organic waste. And a lot of that organic waste work led to projects that we funded and then owned and operated in anaerobic digestion, or AD for short. So what AD really is, it's the decomposition of organic materials. So think of food waste. Typically, there's a lot of kind of manure that's a part of that feedstock as well. So this organic material that decomposes in the absence of oxygen. So when oxygen isn't involved, it creates a source of methane. You would know methane through the natural gas that you burn, right? And that methane can be either combusted to create electricity. And it's a clean form of electricity because there's no kind of fossil fuels. It's kind of waste that was already there, or it could be upgraded and be used in pipelines in lieu of natural gas. And so natural gas has a lot of purposes like heating, power, and industrial processes. And what was interesting about my time there, and really kind of it leads into this pathway that we'll talk about with Kanin Energy, is that there's these industrial processes, there's a lot of ways to decarbonize it. And there's also a lot of waste out there that we can do something more useful with it. And what drew me into the world of anaerobic digestion is that you've got all this organic waste. It's really difficult to decarbonize, methane, and look for substitutes there. And it was kind of this neat kind of niche of bringing those two together. So yeah, loved my time working in that group. A lot of people called me the queen of waste for a while there, I think in a loving way, I hope. Yeah, and I really enjoyed my experience kind of growing that industry and helping to drive the early days of renewable natural gas and biogas, and took a lot of what I learned into kind of waste heat to power and building Kanin today, and being on the other side as well.
Excellent. Well, Janice, thanks for being on the show, and hopefully you're keeping that queen of waste title going forward on your future work there. I like that.
Yeah, different queen. Yeah.
We mentioned microgrids. Can you explain what those are and kind of what their applications are and some advantages they have?
Yeah. So I think what you're referring to is my time at NRG when I was on the microgrids team. So when I graduated from Columbia with my master's degree, I was looking for work in clean energy, and I found this opportunity in Carlsbad, California, which is basically Southern California. Never been there before. My first time there was for the interview, and it was super fun because it was part of this new team within NRG. And at that time, David Crane, who was CEO at the time, made this big splash and commitment to transition NRG, is one of the largest independent power producers in America, to almost entirely clean energy. And so I thought that was a very kind of motivating philosophy. And so I was excited to join the company. Microgrids was a really new thing at that time. And it was cool to be kind of at the cutting edge of how do you use microgrids in this energy transition? So what microgrids is basically you're taking a bunch of distributed energy resources. So you're using solar, you're using batteries, you might be using recip engines, fuel cells, any kind of generation, self-generation. And you're tying it all together with a kind of hardware controller and software that is levelizing the generation to the consumption. These are typically behind the meter. Some microgrids are like fully islanded and some are connected to the grid, but it's really like seen as, a way to like push a distributed energy generation away from just relying on the utility itself. And, there's like some resiliency and reliability benefits and obviously saving on electricity costs and being green as well. So it was really cool to be a part of that. There was some restructuring that happened and, there's a whole kind of drama around energy that you could always read about, pivoting away from that kind of the energy transition. I learned a lot in my time there. And I also got to work with some really inspiring and amazing people who are still my mentors today. So even though I wasn't there for very long, we did a lot. And yeah, I speak, very fondly of my time at Energy.
So you've been a part of investing and developing innovative approaches to energy. You've talked about all the different microgrid applications that you were looking at NRG and things like that. But what really kind of drew you into that as far as kind of being the leader in that space?
Yeah, I've always been motivated by solving climate change. So that's really been like kind of my guiding kind of North Star since I was about 20 years old. So when I was 20, I took this business ethics class and it was just kind of this like epiphany. I was like, okay, I want to commit my life to solving climate change. And I made a promise to myself that when I'm on my deathbed, looking back, I want to be able to like look in the mirror and say that I did everything that I could to, make an impact on solving climate. And so that kind of promise to myself when I was 20 years old has really guided my entire professional journey since. So it hasn't really been like, I want to do investing, I want to be, in development, I want to be a CEO. Like none of that has ever been a goal. It has always been like, at every moment in time, asking myself every few years, like, am I keeping that promise to myself? And am I doing the thing that is the most impactful for climate? And by kind of being guided by that kind of North Star, it's opened up a lot of different opportunities. And so as new opportunities come up, I ask myself that question and it ends up usually leading me down a path that's like more ambiguous, more risky, a lot more work, but at the end of the day, a lot of fun. And I've got to see a lot of like different countries and cities because of it. So yeah, no complaints there.
It's always good to have a North Star, something that you're working towards, right?
Yeah, totally. And I don't know how many of your listeners are kind of early in their professional journey. But I've never really been motivated by like, padding my resume or, any of kind of that kind of stuff. A lot of young professionals will always kind of ask me for career advice. And my advice is always, go for what you're uniquely good at and passionate about, but also just be brave. And I think a lot of people hold themselves back. They don't want to go for that, job or move or whatever because of fear of, X, Y, and Z. And for me, because of I had this North Star, it's kind of overcome all of these fears that would have held me back early in my career.
So what led you and your partners to eventually found Kanin Energy?
Yeah, so Kanin Energy, we've been around since 2020. And as I was kind of, explaining early on in my career, I've always been motivated by these like new up and coming industries, especially in like industrials and in waste, because it's often like overlooked. A lot of people hear about, electric vehicles or like solar or wind or whatever, these like kind of more known and kind of flashy, um, topics or generation sources. And so kind of my interest has always lied in like the thing that's kind of like the underdog or hasn't been getting a lot of attention that can create a lot of impact. Again, going back to like my North Star. Well, the idea for Kanin didn't start with me at all, actually. It started with my two co-founders and they worked together at a geothermal company. And with geothermal, especially before 2020, call it in the 2018 or so, it wasn't cool, not like it was today. And it was very expensive. And, they were building a geothermal company, looking to drill their first well. And I think they were realizing that when you drill into the ground, there's a lot of risk involved. And the resource is not oil and gas, which is like, has quite a big return associated with it to accommodate for that risk. It has power returns, which is quite a bit lower. And so kind of that mismatch of risk reward wasn't, they didn't really love it. So they started kind of looking towards how do you use the technologies of geothermal, which is like organic Rankine cycle, and apply that to other places that didn't involve drilling. And so that led them into this like world of looking at waste heat above ground at industrial facilities and turning that into power. So they started thinking going down that path. And one of the co-founders, Dan Fipke, he's our chief development officer today. And we've, been really good friends from, I think you mentioned Student Energy. We're both, part of the founding of Student Energy. So we, stayed close in contact. And he pitched this idea and kind of like, where there was going. And I said, okay, this sounds really interesting. Going back to that North Star, I think I can create a lot of impact here and start something new and see where it goes. And I really saw this potential where you're self-generating electricity, it's baseload, it's clean, it's behind the meter going back into that industrial facility to help with resiliency. It kind of hit all of these themes that I knew was going to be coming up in the next, call it 5 to 10 years as we saw, energy transition and policy kind of changing. So I said, yep, like this sounds like a really great idea. Let's give it a shot. And that was, June 2020. And it's been a fun roller coaster ever since.
Nice. So I want to ask you about waste heat recovery and how that gets generated power. Quick question though, where did the name Kanin come from?
Yeah, so Kanin actually stands, it means rabbit, like bunny rabbit in Norwegian. We like the sound of it. Why the bunny? So the bunny is my Chinese zodiac sign for one. Like rabbits are very resilient, like super resourceful. They move very fast. They're quick. They're nimble, and they're kind of pervasive. They're kind of everywhere. And we also like the general kind of gentle nature of bunnies too. One of our core guiding principles at Kanin is be smart, be nice. So we're not like out there trying to make a quick buck. We're really there about like adding value, doing it in like a friendly way, a value added way. And so it kind of felt like, that bunny rabbit kind of embodied like what we were trying to build. And then Kanin sounded kind of cool.
Yeah.
A lot of different logos we could like create out of it.
I like it. Yeah. Cause so many of them are just, as the founders' two first names put together. It's like, oh, okay. That's a good answer. I like that. So we have got a lot of different listeners, different backgrounds in the industry. Can you explain what waste heat regeneration and waste heat to power is, just kind of in a general broad sense?
Yeah. So what is waste heat to power? So what we do is we take waste heat from these industrial processes. So think about like oil and gas processes have waste heat. So when you think about a natural gas pipeline, they have compressor stations that basically move the gas through the pipeline. Those compressor stations have waste heat. When you think about gas processing or refining in chemicals, in cement, in steel, and ammonia, a lot of these industrial processes that happen to also be hard to abate sectors have waste heat as just like a byproduct of what they're doing. So what our industry does is, and what our company does as a developer, is we take that waste heat and we turn it into power using a technology typically called an organic Rankine cycle, although there's other technologies that we also use, like the steam Rankine cycle. There's a lot of other kind of unique up and coming technologies out there as well. But the general gist is that you've got this exhaust that's being kind of released, again, this byproduct of that industrial process. We put heat exchangers on it that basically touch that hot exhaust, and then it warms up an oil, and that thermal oil then basically turns a turbine. So if you're familiar with how a steam engine works, you're using a fluid, and a steam engine is water. In an organic Rankine cycle, you're using something outside of water, not water, but has a lower boiling point. And so that fluid then evaporates or vaporizes, and then it condenses. And so that kind of act of like vaporization and condensation, just drives this turbine that creates electricity. That's kind of the simple, I'm not an engineer, so simple kind of like how it works. But, we're seeing, over 15 gigawatts of potential across the United States and Canada. So there's a lot of opportunities to be kind of pounced on. We estimate over 10,000 industrial plants in the US and Canada have some potential of waste heat. And then, that's not even considering data centers as well, which is like, it's kind of, that's lower temperature heat. So it's a little bit harder to get. But, there's lots and lots of waste heat out there. And it's a source of baseload clean power that shouldn't be ignored.
Yeah, I know. Just my company, we have a lot of compressor stations. I saw on your website you guys were doing some power generation on compressor stations. It's always interesting because you have a lot of energy going through there that's being created to move gas, and then of course all those stacks are just emitting tons of heat, right? Because you can't really recover it. So it's pretty interesting stuff you're doing. How long has this been around, this kind of technology, and kind of the way you guys are utilizing it, and why hasn't more companies kind of been utilizing this in the past?
Yeah, so the waste heat to power technology it's a very old technology. It's been around, well, for the engineers in the room, if you're familiar with the Carnot cycle, or you took some thermodynamics classes back in the day, this is really waste heat to power, or that concept has been around since like the invention of the thermodynamics and that kind of those principles. I'd say like the earlier version of waste heat to power is really like the steam engine. So you're taking water, running it through the like I was saying, the vaporization condensation drives the turbines. That's really the steam engine, steam turbine. And I'd say like the most recent version of like what we see today, like the modern version of ORCs, became popular. It was invented in like the 70s, but really became popular, I'd say, in like the 90s and 2000s, when this moved to behind the meter cogeneration and looking at like other ways to self-generate was becoming popular. But I would say like it's been very underutilized. There's a lot of reasons for that. I think the first is it's been a more expensive resource than, say, just like plugging into the grid. And why it's becoming a more real option is because power prices are just going up. And there's a bigger focus on green power as well. And so as we kind of try to look at self-generation, as the grid becomes increasingly unstable, prices are becoming higher, and you're looking to not, exceed your sustainability targets, kind of all these things that point to organic Rankine cycle turbines and waste heat to power kind of start to make sense. I think another thing is just policy. So there's never really been developers out there really like advocating for the industry at large and at scale versus selling equipment. And so the past versions of the industry has really been dominated by technology providers just trying to sell their equipment to the energy manager at a plant. But when you kind of pull in different complexities about what makes a project go. So for example, you need to understand about interconnection. If you're selling it to the grid, you need to understand about, just generation itself, the regulatory parameters around it. You have the investment tax credit, especially in the United States, and you need to go and find a buyer for it. And usually the payback periods aren't going to be like the 24 months and under that a normal energy manager at a site is looking for. It's going to be a lot more than that, usually typically 5 to 7 year paybacks. And so the payback is usually outside of the period of the type of investments that they're looking for. And on top of that, these investments are on the larger end. It's not like you're switching up pumps or making kind of these like small retrofits. This is an entire like power plant on your facility. So all of that together is kind of just a mismatch between, skill sets, time and resources, and just like availability of capital versus like what it would take to actually do this project. And so that's really, why we created Kanin Energy is we saw kind of that mismatch, and we said, okay, well, if we take this model that the traditional solar and wind industry took, which is, developers that didn't create and invent the solar panel. They really took solar panels that already worked, and then they created a business model around it, created financing around it so that the industrial host doesn't have to pay anything, and they get paid kind of day one through an energy services agreement. Kind of take those like business model innovations and apply it to this like discrete technology and class of clean power. We think we can unlock it. And that's exactly what we've been doing since 2020. And So the projects with Tallgrass Energy, we could talk about that. But that our first plant just turned online a couple weeks ago. We're selling 9.2 megawatts of clean electricity, baseload clean electricity to the University of Dayton. We're proud to say that we are powering all of that university with our waste heat, and we're reducing their emissions, hour by hour. And they're actually, I'm not sure if you're aware, but in Ohio there was a really drastic heat wave that kind of swept the state, and some of those points they were saving like 3 times what they were paying.
Wow.
So we're helping them to manage their electricity costs for sure. But yeah, that's one example. We've got 3 other projects that are in construction with Tallgrass Energy on their natural gas pipeline, and then we're working with Phillips 66. We just announced this project about a month ago, but we're working with Phillips 66 on their natural gas processing facility, generating 7 megawatts of power there that is going to be self-consumed at that site.
So you mentioned working on a university and working with other midstream energy customers that a lot of our audience might be probably familiar with, but you mentioned that there could be 15 gigawatts or more worth of potential opportunity. Like, what other industries make sense for these waste heat to power systems, or where are you looking?
Yeah, a fun fact I always like to tell people is that over half of the energy that goes into an industrial process is usually wasted in the form of waste heat. So you're basically looking at most industrial processes. So that a common one, outside of natural gas and like oil and gas is cement and steel. So you're seeing a lot of those furnaces have this waste heat, ammonia or chemicals, facilities. Yeah, I think look into your industrial process. If there's, we're looking for temperatures over and above about 100 degrees Fahrenheit and something, kind of consistent. So if you have that, then you're a good candidate.
So given that it can kind of be used in a lot of different places. I mean, what are kind of the biggest obstacles you've seen to widespread implementation other than just kind of the most recent time, change or power cost change?
Yeah, and like I was saying earlier, I think the biggest obstacle that we've seen is, the industrial host not understanding how we could help them do it efficiently. This is not like an equipment change out, right? So it's quite complex. I think the biggest hurdle that we see right now is just convincing that industrial host on the other side that Kanin can come in and really, take this project to execution. And it's not no work, but it's much less work than they think. And especially if we come in with the capital for it. And so there's always this kind of, conversation of like, okay, well, is the juice worth the squeeze? And we always have to kind of model out, what is the benefit for you? And it kind of changes depending on a combination of, what are your goals? What are your power? What do you think power prices will be? And what are you looking for? But there's always some benefit here, and we can, as a developer, can come in and like really help actualize that. So that's probably the biggest barrier. I'd say the second barrier is just a policy. In Canada, we're especially seeing this. We're getting a lot more traction in the United States because of policy around the investment tax credit and things like that. But in Canada, our technology by nature is kind of a smaller technology. When they created that investment tax credit in Canada, they forgot to include us. They probably didn't even know that we were really there. And so it's been kind of this uphill battle to get that included. And that policy framework really does impact like how we implement. And even the state policy side too does impact, like if you get renewable energy credits and things like that.
And that's an interesting business model, and hadn't really thought of that because so much of industrial economics are built on rarely pretty short-term gains, right? To spend a lot of capital, you're wanting return pretty quickly. So, thinking about and actually having some investment from your company to put this in, that's kind of an interesting difference. And I actually don't know if too many people are aware of that one. I could see that definitely helping sell kind of more of a long-term solution to energy gains. And then especially, we're seeing a lot of power problems, right? So we're having power availability issues with utility providers, and so it's getting more and more difficult, and I foresee that coming up in the future more. So there'll probably be lots of opportunities for you guys. So what is next for Kanin Energy? Is there other types of innovations on your radar besides waste heat recovery?
Yeah, so we started with waste heat to power, but the idea has always been to land and expand into other technologies and processes. We really see ourselves as the partner for industrials to implement efficiency solutions or power solutions. Waste heat to power was one technology that we were testing as a pilot, but the idea is to do many more. So combined heat and power is something that our partners are asking us to look at. So this especially works when you have, say, lower gas prices, you have higher electricity prices, and you're able to kind of take that arbitrage, or you're looking to reduce your scope 1 emissions. You have higher power prices as well, so you can decrease your gas consumption by taking the wasted heat from power generation that you're self-generating using gas. And then offsetting your emissions that way. So it's not net zero. So there's still some incremental emissions, but it can in many times be lower than what your kind of status quo emissions are. And I think at the end of the day, you're also saving money, which is kind of what is motivating people, especially nowadays. We're also looking, any other type of technologies. We're always on the lookout for new technologies, but any other technologies that can really save money and help reduce reliability issues for industrial customers is something that we're always looking to add to our kind of menu of options. So I'd encourage, if any of your listeners out there are looking for solutions, like all kind of encompassing solution provider for energy, is looking to build kind of infrastructure, like we'd be happy to step in and take a look. And the innovation that we have is like it's a full suite of services. So we do all of our engineering for free, right? Like we don't really charge people for that work to see if there's a viable solution out there. That's not just kind of how our model works. And then as we find a successful solution, that's like how we get paid. And a lot of times we'll own that piece of infrastructure ourselves. And so that's how kind of we make our money, is by building things that work. Not all the time is it like in line with, say, engineering firms or equipment providers. They're really trying to like say, hey, I want to upsize this and maybe kind of go beyond what is needed at that host. For us, we're really looking for like what's going to maximize value for the customer and in turn create returns for us. So yeah, it's kind of a different approach to servicing the customer.
So Janice, first off, thank you for coming on. It's been super interesting, and I hope that this technology, and this information gets out to every one of our listeners, just because I think, people can use it, right? It seems like a good opportunity to at least look into it. But one thing we always wrap our podcasts up with is the same question, and I think it very much pertains to this. So, you're back on this podcast in 3 to 5 years, right? And you're happy about how things are going, happy with the energy industry. What's happened over that time frame to make you be happy?
Yeah. Well, first of all, I'm glad that in 3 years you guys are still, spreading the good word. So that's great. Yeah, I'd probably say success to me, or like what makes me happy, is just putting electrons out into the world, whether that's supplying a grid or supplying these industrial users. So in 3 to 5 years, we hope to have a pretty healthy portfolio of operating assets of clean electrons that are, generating value. I think for me personally, I'm a first-time CEO. I haven't really done this before. It's just been really fun to like build a team and create jobs, create community, and create impact. So a big motivating factor is just having a really solid team of amazing people that are having fun and are making a difference, and hopefully, spreading that into the community as well. That would make
Awesome. Well, once again, thank you so much for joining us, and we're happy to help spread the word, and I wish you the best of luck, and definitely hope to have you back on in the next few years, right? Hear about those new projects. And to our audience, thanks for joining us again, and we look forward to catching you on the next Clear the Air podcast. Have a great day.